All right, so today I'm going to show you how to do partial fraction decomposition. And the idea here is, given this condensed rational expression, the goal is to decompose or break it down into two partial fractions. So that condensed rational expression, 2x plus 1 over x squared plus 5x plus 6, you want to express that into, here you have two partial fractions or two simple partial fractions. So suppose we have an example. Okay, suppose we have an example, say x plus 4 over x plus 2 times x plus 3. Okay, so we have this one single rational expression, and we want to express this or break it into two partial fractions. Now, the first thing we have to check is whether the degree of the numerator is smaller than the degree of the denominator. So you can see here the degree is 1, and the degree of the denominator is 2 because, x times x is x squared. So that's second degree. Then after checking that the degree is lower from the numerator compared to the denominator, then we can start setting up our partial fraction. And the first denominator is this x plus 2. So this shortcut I'm going to show you works when these factors, which are linear factors, are distinct. Okay, so we have these linear factors that are distinct. So you're going to set up your denominator, one for x plus 2, the other for x plus 3. And our goal is to find this constant a, also constant b, such a way that, when you combine these two fractions, we get this original condensed single rational expression. Okay, so let's jump right into our main procedure here. All right, from this denominator x plus 2, if you solve for x, okay, then your x is going to be equal to negative 2. Now, on the other denominator, when you set this x plus 3 to 0 and solve for x, your x is going to be equal to 3. All right, so we're going to find the a and b now. Okay, so for both columns here, I want you to write down the original rational expression, that x plus 4 over x plus 2, x plus 3. On this side, you do the same, x plus 4 over x plus 2 times x plus 3. All right, now when you plug in the value negative 2 to x in this rational expression, okay, so when you plug in the negative 2, what's going to happen with this part of the expression? This part becomes 0, negative 2 plus 2. And because the denominator is 0, then it's going to be undefined. Okay, so what we do is cancel this out to make the calculation possible. And then after you cancel out the x plus 2, now you can plug in the negative 2. Okay, so plug in the negative 2 to x. So we get the negative 2 plus 4 over negative 2. Okay, plug into that x plus 3. Now we have what? 2 over 1, or simply 2. Okay, now that is the value of your a. So your a is going to be equal to 2. Okay, so a is equal to 2. Now what about the b? When you plug in the negative 3 to this expression, this part becomes 0, and that denominator becomes 0. The whole fraction becomes undefined. So we're going to cancel this out before you plug in the negative 3. Okay, so let's plug in the negative 3. Negative 3 plus 4 over negative 3 plus 2. That's 1 over negative 1. Okay, so which is negative 1. So your b is -1. All right, so our x plus 4 over x plus 2, x plus 3 is going to equal these two partial fraction 2 over x plus 2 minus 1 over x plus 3. Okay, so there we go. That's the partial fraction decomposition of this condensed rational expression. Now you can check that. Okay, so you can check that by adding these two fractions. Okay, so let me show you how to check. Right, so let me erase this part of the. Okay, part of the, I need a space to write on, so I'm going to delete this. Okay, so let's go ahead and check. We say that this is equal to 2 over x plus 2 minus 1 over x plus 3. All right, so to check, what we do is combine these two partial fractions and see if we get this condensed rational expression. So I'm going to make the denominators the same. Okay, so I'm checking now. What I'm going to do is multiply this by x plus 3. Multiply the top also by x plus 3. That's equal to 1. And then this second fraction here, I'm going to multiply by x plus 2, then x plus 2. Okay. See, now that they have the same denominator, I can just write the combined fraction with that same denominator, x plus 2, x plus 3. And then I will just simplify the numerator, so that's 2x plus 6, okay, minus x, okay, minus 2. Now 2x minus x is equal to x. X plus, sorry, 6 minus 2 is 4. Okay, over that x plus 2, x plus 3. All right, so that means it's correct. Okay, so we got the two partial fractions correct. Okay, let's look at the second example. Let's say we have 2x plus 1 over, okay, x squared minus 8x plus 15. Okay, so let's check first if the degree of the numerator is less than the degree of the denominator. Okay, so that's 1 and this is 2. Since the degree of the numerator is less than, then we can go ahead and set up our partial fraction. Okay, the thing is, this denominator is not factored. So what we do is go ahead and factor it if it's factorable. Okay, so that's x and x. Now for factors of 15 with some -8, -3, and -5. Okay, so those are the linear factors. And again, they have to be distinct. Okay, so we can be able to use this shortcut. Since they are distinct, we can go ahead and use our shortcut. So that denominator is x minus 3. This other denominator is x minus 5. And then our numerator is constant a. We're going to look for that. And this other partial fractions with numerator b. Okay, so we're going to go look for a and b. Now let's solve for x from this x minus 3. So x is equal to 3. And then on this x minus 5, the value of x is 5. Okay. All right. So let's go ahead and start doing the substitution. Before we do plug-in, let's copy the 2x plus 1 over this x minus 3, x minus 5. Okay. So we're going to need to do that same 2x plus 1 on the other side, x minus 3, x minus 5. Again, when you plug in the 3 to this rational expression, okay, this part becomes 0, so you don't want that 0 underneath because that will make this undefined. So once you cancel that x minus 3, then you can go ahead and plug in this 3 to x. So that 2 times 3 plus 1 over All right, plug in this 3 to x here. That's 3 minus 5. Now 6 plus 1 is a 7 over negative 2. All right, so that's your A, negative 7 over 2. On the second column, our x here is 5. That will make this part of the expression undefined. Okay, so we're going to cancel this x minus 5 before we plug in this value 5 to x. Okay, so let's go ahead and plug in the 5. So that's 2 times 5 plus 1 over 5 minus 3. So 10 plus 1 is 11 over 2. That's the value of b. All right, so those are the two partial fractions, partial fraction decomposition of our condensed rational expression. We have negative 7 halves over x minus 3 plus 11 over 2 over x minus 5. This is the partial fraction decomposition of this rational expression. All right, so I hope you learned something from this short video, and I will be posting a second part of this concept. Okay, so see you again. Thank you for watching.